What is flame rectification? How do you make your own flame test rod, a tool that you can keep with you so that when you're doing service, you can check the flame sensor and see if it's good in the field? What happens when you have a bad flame sensor? What's the most common problems, and what does it do to the furnace during the heating operation? How do you use your meter to check flame rectification and check your flame sensor and make sure it's good? Today you're watching HVAC Tips for Technicians. I am Tad, and we're going to learn all about flame rectification, flame sensor, how to make your own test rod, and how to check with a meter in the field. Today I want to give you more knowledge. I really appreciate the question from the viewer. Can you do a video about flame rectification in detail? So today I am making your question content. Really appreciate it. Before we start, hit that like button, subscribe, hit the bell, ding. Please share this video, and if you have any comments, put those down there in the thread below. If you have any questions, I love questions, but definitely tell me who you are and where you're from. I love to know my viewers, and I really appreciate my subscribers and definitely my members. If you want help with your project, you want help with HVAC tech support, you want my contact information, click that join button. Go down below, let me know, say I joined, and I will get with you. I'll give you my email, and that can lead to my phone number. Before we go check out the operation of this furnace and use our meter to check a flame sensor, and before we make that nice flame electrode test rod to be able to check flame sensors, let's go over flame rectification. What is flame rectification? Well, it's super simple. Flame rectification is the process of using a flame, whether it's a pilot flame or a burner flame, to change a small AC current into a DC current. Look at the word flame and then rectification. If you break down the word rectifier is a device used to change a AC current into a DC current. Now let's talk about this little setup I have here and go over how we're going to use our meter. So this right here is my meter, okay? And I'm going to use my UADC right there setting to be able to measure the microamps. And typically we're going to have in between 0.5 and 10 microamps common. 2 to 6 is common as well, but it depends on your furnace. This right here is my ignition control board, and this is where my AC signal is sent out, okay? And that signal is sent out, and as soon as that flame is present, then our flame sensor basically sends back a microamp reading, and this right here is where it's plugged in. See, it says flame right there on this board. And the way I measure my flame sensor and the microamps is I put my leads in series. One lead goes in here, okay? And then the other lead goes right here. And I'm basically measuring in series that microamps coming from my flame sensor back to my ignition control board. And it's able to tell whether I have flame presence or absence. If I don't have any flame, that means it's going to de-energize the gas valve, and it's no longer going to open the gas valve so we don't have gas buildup in our furnace. Now, before we go check out the furnace operation, talk about most common problems and what to do about them, we're going to make a flame rod sensor that we can use to be able to test flame sensors. Let's go. So how do we make our own little flame electrode, flame rod, so that we can test flame sensors? Well, it's super simple. You take some copper conductor, number 10 preferably, and then this right here is tape. So pretty simple. Also, you might need a spade connector. It just makes it a little bit easier. I would use a male spade connector, and you will need a crimping tool to crimp that on one end of this. So let me show you what you do. So you can make it whatever length you want. You want to bend one end down because this is the end we're going to put in the flame, and then this is the end that we're going to connect to the wire that was connected to our flame sensor. And then what we're going to do is we're going to tape this rod up, and we're going to tape it all the way up because of course you don't want this touching the frame or the burners or anything else, because it's not going to work if you do that. So I'm going to tape this up, and remember, you might need to get some crimping tools and get a spade connector. So remember that, a male spade connector, and I'll show you why. A little homemade DIY testing rod here is almost complete. You can see I've got it taped up the whole length of the rod almost. This is where I'm going to put my crimp connection on. I found something that would work because I didn't have a single male crimp connector, but I had a double male crimp connector, and this right here is a female. So basically going to put this on and then put this in here and then bend one of these back so I can make my check. Oh yeah. It is complete. So the wire that goes to the flame sensor, I'm going to plug it into there, and then I'm going to be able to use this in place of the flame sensor that's existing. The most common problem you will have with a flame sensor is it's dirty. What do you do about it? You clean it. This is some sandpaper, and I use this on a regular basis, not only to clean burners, I also use a steel brush, but I use this to clean my flame sensor, my flame rod, because when it gets dirty, it gets rust on it, it no longer senses flame, then the flame goes out. So let me show you how to use my meter. We're going to take this flame rod out. I'm going to show you how I clean it, but let's go ahead and use our meter now, show you how to check microamps on this flame sensor here. All right, let's go. All right, so flame is burning. We've got our SC440 Fieldpiece set to UADC. Turn my little light on so you can see it. There's my flame sensor. And I take this off here. And what happens when I take it off? Whoop, flame goes out. Exactly. All right, now I'm gonna go ahead and take and hook my meter leads up and show you the reading. All right, so you can see I've got my red meter lead on the flame sensor rod itself and the other lead on the wire leading to that flame sensor. So that wire now leads back to the ignition control board. And you can see I've got 1.8, 1.9 microamps. Look at that, it's pretty awesome, huh? And it's still lit because of course I'm using my meter and my leads to make a series circuit. So once I remove my lead, watch what happens. It goes back out. Isn't that awesome? Super easy how to check this. So if you don't have any reading, then your flame sensor is definitely bad. But we've got a reading, and that's how you use your meter to check microamps. All right, now let's move forward and use our flame rod that we made to be able to test. Now let me show you how that little flame testing rod works and talk about how you install that. Let's go. So this right here is the testing rod. You can see that most of the body is wrapped in that tape, and that is because we only want this section in the flame, and we don't want any of this touching anything, any of this copper bare wire touching anything. Otherwise it's not going to work. Now if you don't have enough room, it looks like we don't really have enough room to put it in the flame at the last burner. So what we're going to do is we're going to take our little 1/4-inch nut driver, and we are going to take out our flame sensor. Pretty simple. This is our flame sensor, and look at it. It's actually pretty dirty. So I definitely need to set that to the side. Use my sandpaper to sand that and clean it up. All right, now this is our little testing rod. We're gonna put it in there. Make sure it's not touching anything. All right, now we're gonna turn the furnace back on the heating operation. All right, now flame should light across the burners, and our flame sensor that we made should work and keep that flame lit. But you got to make sure that it's not touching any of the metal, that the part that you have that's untaped is in that flame. Hot surface igniter is glowing, gas valve should open. We've got our flame sensor connected and it is in the flame. All right, here we go. Now as long as it's in the flame properly, it should stay lit. If it's not, it'll go right back out. And it is staying lit. If you have a situation where your flame keeps going out, you take the flame sensor out and you clean it and you put it back in, it's still going out, then you can use this test rod in place of that flame sensor, and then if the flame doesn't go out, then boom, you know you got a bad flame sensor. You order the flame sensor, or you take one from your vehicle and you put it in, and that is a way that you can test the flame sensor. Look at this flame sensor now after some sandpaper treatment. Look at that. Nice and clean. Now I can reinstall it in its location, and boom. I hope you liked today's video. I hope you enjoyed it. I hope you learned something. If you did, comment below. Let me know you did. Hey, before you leave, hit that like button. Boom. That helps me. It helps my channel to grow. We can be helpful or we can be hurtful in this life. I choose to be helpful, and I hope you choose to be helpful as well. Help other people see my channel by helping my channel grow, by subscribing, by sharing, by liking. And if you need help, remember, leave a question. Questions become content. That's how this video started. Somebody about 3 weeks ago said, hey, can you do an in-depth video about flame rectification? So that's what happened. Really appreciate my subscribers and definitely my members. You really, really don't know how much I really appreciate you. It's awesome what you do for me. Thank you so much. This has been HVAC Tips for Technicians. I am Tad, and I'll keep you cool if you let me. And if you want to stick around, you're a new HVAC technician, or you're thinking about becoming an HVAC technician, and you want to go over sequence of operations, I'm going to go ahead and give you more information about what can go wrong with gas furnaces, how to check them, what an 80% is, and let's just learn more. All right, let's go. So for those of you that are sticking around, I'm glad you're here. I'm glad you're ready to learn more. Today I'm going to go over what an 80% furnace is, what components, what sequence of operation is, what happens, and then what happens and what happens and why. All right, let's go. So first things first, this is an 80% furnace made by York, and it's 80% meaning that it burns 80% of the fuel and it wastes 20%. I want to go ahead and show you all the components, but we'll get it fired up and then talk about sequence of operations here. So this is my inducer motor assembly, right? And this is my pressure switch and my pressure switch tube, and then my fitting on my inducer housing. This is the flue pipe. It's 4-inch single wall pipe. It's a non-condensing furnace. It's not 90%. That means we don't have a drain. We don't have a PVC flue vent. We have a metal, galvanized metal flue vent. So what happens first? Well, my thermostat calls for heat, and what does it do? It takes and it closes the R and the W, which if you measured, once the R and the W are closed together, then you have 24 volts to C and W. So you would read C and W to have 24 volts, and this board sends signal first to energize the inducer motor. Now, why does it do that? It does that so that it pulls the flames through the burners. And when it pulls the flames through the burners, creates a negative pressure. And that negative pressure pulls on this diaphragm of this pressure switch, which is a safety. Once it closes, then this right here will send signal to my hot surface igniter. And my hot surface igniter is a carbide igniter, and it glows. Why does it glow? Because there's 120 volts that's sent to these wires. So it glows, and then once it glows, oh, we got all the other safeties first. Hold on. Pressure switch closes. All these remain closed. This is a rollout switch, and this is a rollout switch, and this is if the flame rolls out. So I have to give you that first too. And this is the limit switch. I have to show you that as well. So this is a limit switch, and if this gets way too hot, and if you'd ask how hot, it says 150 degrees. So if this surface area gets 150 degrees or more, then it will open this limit switch, therefore impeding the operation of the heat. So back to the hot surface igniter. So pressure switch closes because the inducer motor is running. Hot surface igniter is applied voltage from the board, and it's glowing. Now what happens is the gas valve has 24 volts from the board that is applied to it. So if you measured from this wire to this wire, you'd have 24 volts, and you would use your VAC on your meter to measure that. Now what happens once the gas valve opens is gas goes through this manifold through the orifices into the burners, and the hot surface igniter provides the ignition, right? Boom, it lights up, and then you're supposed to light all the way across the burners. If you don't, you could have a problem with your track not being lined up, or it could be the burners are dirty and need to be cleaned. Then over here at the flame sensor, we're of course going to sense the flame and send that signal back to the board, okay? And then that is going to keep our flame lit. Now, our blower motor is going to turn on as well. So that is the sequence of operations. Let me know if you have any questions about that. And as always, thank you so much for watching. You rock. Appreciate it. This is Tad reminding you, I will keep you cool if you let me. Please subscribe.